Okay, so I found this simple way to develop an interactive grass shader and I wanted to share it since there aren't many tutorials on the topic out there. First off, I've made the stylized grass blade in Blender, and I've also made a lighter version with less vertices for my LOD. As far as the UV is concerned, I pretty much simply projected it from view. So the shader can be divided into two sections. The first section is where we make the wind effect, and the second section is where we take into account the player position. I'm going through the process using a shader graph, but of course you can do the exact same thing with the Amplify shader. By the way, in this example I'm going to use an Elite shader, but you can use whatever kind of shader you want, as long as you can modify the vertex position and change the basic color. Okay, let's begin with the wind effect. We start with the world position that gives us the position of the surface of the geometry in world space, and we isolate only the x and z axis since, the wind moves horizontally. We then multiply that for a variable called wind intensity, so that we can regulate how much the wind impacts the geometry. We then add a tiling and offset node whose job is to pen the UV coordinates. To move the UV over time, we feed in it a multiply node that takes in the time and a variable called wind scroll. Then we feed that into our noise generator with a variable called wind scale. As you can see, with a scale small enough, the noise lerps between grey and white, but to make it so that geometry jumps between being moved by the wind and not at all, we need to go from black to white. To achieve that, we subtract a 0.5 from the output of the noise generator and then multiply the result by a factor called wind strength to obtain the full range. Let's add the current object position to it and plug it into the vertex position and see what happens. As you can see, our grass now moves in the wind, but it slides on the ground as well, because we aren't locking its position on the y-axis, so let's keep that in mind because we'll fix that later. Okay, now let's move on to the interactivity. First off, we will create a public vector3 variable called the player position, and we will set its position manually to 0, 0, 0. In the shader, we calculate the distance between the player position and the position of the grass blade, and then we multiply the result by a radius that determines the area affected by the player, and then we add the saturate node. If we plug the result into the basic color, you can see the area that is affected by the player position. We are almost done with the shader. The last thing we need to do is put it all together. As I said before, for this example I'm using an Elite shader, but you can use whatever shader type you want, as long as you can offset its vertices and assign color to it. As far as the color is concerned, I want to have two different colors, one when the grass blade is close to the player and one when it's far away. To do so, we simply use a lerp node where the alpha value of the node is the player position and the input A and B are two different gradients. Nice, so now our grass has a different color based on the distance from the player. The last thing we want to do is to properly offset the geometry. Let's start by preventing the grass from sliding all around, and to do so we multiply the wind for a sample texture 2D load containing a gradient. This gradient will tell our grass vertices if they can move. Since the bottom of the gradient is black, the vertices close to the ground will be stuck, while the one on top will be able to move. Okay, so the issue with the grass sliding is fixed now, but we need to still take care of the grass scale based on the player position. What I want to do is to keep the grass at its normal height and increase its size when it's far away from the player. To do so, we need to lerp between the vertex position and the vector3 equal to 0, 0, 0, and then add to it the position that takes into account the wind. What happens is that the grass close to the player keeps its size, but the grass that is far away is twice as big. Nice, so now we are done with the shader and it looks good, but at the moment the player position isn't updated. To update it, we need to create a simple script that feeds the current player position to the variable in the shader. This script takes in the player transform and the material, and every update the player position variable in the material is updated. By the way, to know the name of the variable in the shader, you can find it here. And that's it, an interactive stylized grass shader. In the description I'll also leave my publisher profile, since I'm planning to publish all this stuff as a free asset. I don't know if the asset will be up when this video is published, so you can check there. Cheers!